Welcome to Spring LIB.
For this problem on the topic of energy, we are told that a moving hammer hits a nail and hence drives it into a wall. We want to know what happens to the depth that the nail will be driven if the hammer hits the nail with twice its initial speed and then with 3 times its initial speed. So we'll let the original speed of the hammer be v1, and then we will double that and then triple it. So v2 is twice v1 and v3 is 3 times v1. Now, let's assume the hammer is moving with velocity v1. So it has kinetic energy, a half m v1 squared. Now, we'll assume that the hammer comes to rest after striking the nail. Hence, all of the kinetic energy from the hammer will be transferred to the nail. In the process, work is done to the nail in driving it into the wall. So some force, F, is exerted onto the nail and it's driven a distance d into the wall. So the work done is F times d. In this case, that will be d1. Now, we know the force by Newton's second law is the mass times the initial acceleration of the nail, and that's multiplied by d1. So we'll assume the initial acceleration of the nail is the same in all three cases, but only the depth at which the nail is driven to the wall changes. So if we rearrange this equation, we find the initial depth of the nail into the wall, d1, is equal to m v1 squared over 2 times f. Now, let's increase the initial speed of the hammer to twice its original speed. So in this scenario, we have a half m v2 squared is equal to f times d2. But we know v2 is twice v1, so we can write this as a half m, and that's 2 v1 all squared is equal to f times d2. And we can hence write this, so we can bring the 2 squared to the front, and that becomes 4 into a half m v1 squared is equal to f times d2, which implies that the distance that the nail will be driven into the wall, in this case d2, is equal to 4 into m v1 squared over 2f. And so we can see that this is 4 times d1. So that means if we double the speed of the hammer, the distance that the nail will be driven into the wall increases by a factor of 4. So d2 is equal to 4 times d1. Now, what happens if we increase the original speed of the hammer to 3 times its original speed? So a half m v3 squared is equal to f d3, and we want to calculate d3. We know that v3 is 3 times v1, so that's 3 v1 all squared is equal to f d3. So this becomes 9 into a half m v1 squared is equal to f times d3, which implies that the distance that the nail is now driven into wall, d3, is equal to m times v1 all squared over 2 times the force F, and all of this multiplied by 9, which we can see is 9 times the original distance, d1. So if we triple the initial speed of the hammer, the nail will be driven in 9 times further than it originally would.